Hello again. This is going to be the 6th video in our series going through all the problems from the standard quiz model, trying to give you a good idea of what those questions look like and support as you're trying to work your way through and improve your score. So once again, we're focused on AP Calculus AB's standard quiz model. This time we're going to look at question number 6, which asks you to evaluate the limit, and we're going to use only techniques that are taught during the first half of the course. So in case you happen to know what L'Hopital's rule is, we won't be using any of that. We're going to be focused only on traditional techniques, our quote-unquote trimming the quills. So let's start with a very straightforward first example. So we've got a rational function, and we want to evaluate the limit as x goes to -5 for that rational function. Before we do anything else, a good place to begin is to perform some direct substitution, make sure it's there. But we have to be careful not to say that it's equal to something that isn't a number. So to begin things, I'm going to start by looking at the limit on both the numerator and the denominator. So if I plug in -5 up here, I'm going to have 2 times 25 is 50, minus 55 plus 5, which equals 0. So now that does limit us here. This gives us the possibility that our limit's equal to 0 or possibly indeterminate. If we plug in -5 in the denominator, we get -5 plus 5 equals 0. So since that gives us a ratio in the limit of 0 over 0, that tells us that we need to do a little bit more work. This is an indeterminate form. We need to do something to determine it. So from here, what I'm going to do is I'm going to focus my attack on anything that I would if it were a rational function. So in particular, I'm going to factor this. So I'm going to do the limit as x goes to -5 of this ratio. And of course, the numerator is where the actual work's going to have to be done. So we've got 2x squared plus 11x plus 5. So as kind of a general tip, you may have already realized this yourself as you're working through the problems from this particular lesson. But if we're trying to evaluate this limit, we need to make sure that we get rid of that factor that produces the 0 over 0. So there should be an x plus 5 factor in the numerator, and then just kind of looking at the original leading term and constant, we can determine that the numerator should factor to 2x plus 1 times x plus 5. The reason that's valuable, of course, is that the x plus 5s will divide away. In the limit, that's okay. I know that they would be equal to 0 over 0, but in this we're okay, which means in a sense we can transform our limit into a determinable one, which is the limit as x goes to -5 of 2x plus 1. And from here, because there's no denominator, we definitely won't get an indeterminate form. We can just direct substitute. We'll get 2 times -5 plus 1, which is going to be -10 plus 1, also known as -9. So our first one, the first trim in the quills technique, is just factoring and simplifying as best we can. So we made a 1, and we were able to evaluate this limit very easily. The second example, B. We're going to begin the same way. You're going to notice I'm going to always begin this way, just to check and see if maybe direct substitution saves us some time. So in this case, if we plug in 4, since this is the limit as x goes to 4 of the ratio between the square root of x plus 5 minus 3 and x minus 4, if we plug in 4, we get the square root of 9 minus 3, which is, of course, 3 minus 3, or 0. So it looks like we're going the same direction as before. In our denominator, if we plug in 4, we get 4 minus 4 is equal to 0 also. Once again, we have a ratio of 0 over 0 in the limit, which means we need to do some algebra to trim the quills and simplify this guy a little bit. So for this one, because of that square root up there, we're going to use the second technique, which is called rationalizing. We're basically going to multiply up and down by the conjugate of whichever part has that radical, so that way we can transform it into a factorable factor. So in looking here, basically my denominator is going to stay the same. My numerator is temporarily going to stay the same as well. What we're going to have to do, though, is we're going to have to add some parentheses, because we can only multiply up and down by the same thing, otherwise we've changed the problem. So I'm going to multiply, as I said earlier, by the conjugate, which is the square root of x plus 5 plus 3. And I've got to do it in the denominator as well. So there is our new limit. Like, this is just kind of a new algebraic form of it. Doesn't look like it's gotten better, but of course, it's always darkest before the dawn. Sounds very profound. So in here, as we look, in our numerator, we have a difference of squares. So we're going to do the limit as x goes to 4 of that difference of squares. That's going to give us the square root of x plus 5 squared minus 3 squared. And in our denominator, yeah, we just have stuff. Like, there's just really no shorthand way around it. We've just got a lot of stuff to deal with. And I can't really do anything about it. I've just got to attack. Now in our numerator, though, it's worth pointing out that we get x plus 5 minus 9, which means when we go to actually simplify that numerator, we're going to end up with x plus 5 minus 9, also known as x minus 4. The reason that's helpful, hopefully you can see already, is because our denominator features a factor x minus 4. And in fact, as we take the limit as x goes to 4, we got 0 over 0 because of that x minus 4 in the numerator and denominator. That was kind of embedded in that numerator and definitely in the denominator. So what I'm going to do is I'm going to divide them away, make a 1. That's going to leave me with a much simpler limit. Now we have the limit as x goes to 4. Now be careful, the numerator has divided away, but that doesn't mean there's no numerator anymore. It's just equal to 1. And our denominator is just the square root of x plus 5 plus 3. So from here, now that we've gotten rid of everything else, our numerator will never be 0, so we can't be indeterminate anymore. We've got 1 over the square root of 9 plus 3, which is going to be 1 over 6. So in this case, we use the rationalizing technique by multiplying up and down by the conjugate, and that was able to lead us through the second question. For our third one, it is going to be the third technique that we have. In this case, we're going to be finding a common denominator, at least assuming that it does require us to use some sort of trimming the quills techniques. So as with any other limit, this one, the limit as x goes to 3 of quantity x minus 6 minus 1/2 over quantity x squared minus 9. This one, we can begin by looking at the numerator and denominator. Our numerator becomes 3 over 6 minus 1/2, which is of course 0. Our denominator is 3 squared minus 9, which is 0. So of course, once again, this means that we need to work our way through and do some algebra to find a function that agrees everywhere, except at x equals 3. So in order to attack this guy, I'm going to begin by doing two algebraic things. First thing I'm going to do is I'm going to factor the denominator, just because I know that eventually I'm going to need to get rid of that x minus 3. That's what's causing us this problem. Second, as I look at this numerator, I've got x over 6 minus 1/2. I'm going to multiply up and down by 3 on that second fraction to get a common denominator. In fact, that will transform my numerator into x over 6 minus 3 over 6. And if we do just a little bit of simplifying of this expression, we can actually transform that numerator into x minus 3 over 6 divided by x plus 3, x minus 3. Now, algebraically, of course, some people might be able to see that we can just divide away the x minus 3's. But just to play it safe, the way that you could simplify this down into a single fraction, so it's really clear what's happening, is we have a fraction divided by an expression. Of course, you multiply by the reciprocal of the second fraction. So in other words, this will become x minus 3 divided by 6, x plus 3, x minus 3. So with that in mind, now we see that our x minus 3's will divide away. This means that our limit is going to be 1 over 6 quantity x plus 3. Once again, there's no more indeterminate form for us to worry about with that 1 in the numerator. It means we can directly substitute. We'll get 1 over 6 times 3 plus 3, which eventually yields for us 1 over 36. So there it is once again. Get a nice clean final answer. But again, we did have to use the common denominator technique. I know what I called in class common denominatorization. Make up a verb or noun for it. And anyway, we get our value here. Now our fourth example in this case is one that could show up as well. This one's not actually as algebraically demanding. This is more conceptually demanding. In particular, we have a one-sided limit. That plus in there tells us that we're focused on only one side. So we have to identify the correct side itself and then plug into the right thing as well as evaluate it. So in this case, because we're looking at the limit as x goes to 3 from the right side, that means we want to deal with the part of the function that occurs when x is greater than 3. Looking at our function here, our piecewise function, we see x is greater than 3, means that the function value is going to be the cube root of 7x plus 6. So in other words, if we want to go and evaluate this limit, we want to evaluate the limit as x goes to 3 from the plus side of this thing. I wish it was called f of x or something, but instead I'm going to be stuck writing it down. As we look at this guy, this is going to actually be equal to what happens when we plug in 3 to the cube root of 7x plus 6. And in this case, of course, that is a correct final answer. That is fully correct. But we can simplify this a little bit, I think. Why not? This is 21 plus 6, which is the cube root of 27, which is 3. So we get a nice answer there. So keep in mind, although the algebraic techniques are really important and probably going to be the focus of the standard quiz question, we could also ask you to do a one-sided limit in this case as well. Now finally, the last thing to bring in here In our plus question, basically my strategy is typically to ask you something a little bit more demanding, typically algebraically demanding. So in this case, we have a function that we want to evaluate the limit as x goes to 1 for, where we have both a radical expression in the numerator and a rational expression in the denominator. So basically this is just kind of a mix of techniques, so we have to be really good algebraically at keeping everything in place. So first and foremost though, it doesn't matter if it's a plus question or regular, I'll start by evaluating the limit as x goes to 1 from the numerator and denominator. In my numerator, I get the square root of 4 minus 2, which is definitely equal to 0. And in my denominator, I get 1/3 minus 2/6, which is also 0. So this tells me that, yeah, of course, this isn't a trick question, a joke question. We actually have to evaluate some stuff. So as I go to attack this thing, the first thing I want to do is I want to clean up the denominator. I think the denominator is going to be the worst part here because we've got all that stuff down below the fraction bar. So I want to focus on that before I worry about the rationalization and the conjugate work that we're going to do. So first and foremost, my numerator is going to stay the same, square root of x plus 3 minus 2. Down below though, I need to get a common denominator for both this fraction and this fraction. So as I look, I'm going to need 1 times x plus 5 over 3 times x plus 5. And then for our second one, I'm going to make it plus a negative. You may have seen that trick before. I learned it from Ms. Nakamura. So we plus negative 2 times 3 over 3 times x plus 5. So this cleans up our denominator just a little bit. Our limit now reads the limit as x goes to 1. We have that square root minus 2 in the numerator. In our denominator, we now have x plus 5 minus 6 all over 3 quantity x plus 5. So we have definitely cleaned this up a little bit more. And in fact, if we wanted to, we could even clean this up one step further. So we'll do the limit as x goes to 1 of our numerator. You can see that I don't get bored or annoyed having to write these things numerous times. You guys might. This is all over x minus 1 times 3 quantity x plus 5. So from here we have everything kind of set up. You can see it's going somewhere. But I want to go one step further, and I want to deal with the fact that we've got a fraction in the denominator. So as we said earlier, if you're going to divide by a fraction, you can multiply by its reciprocal. In fact, there are some cool ways of doing this. In fact, I'll use one of the techniques that a student from last year's calculus class, Carmen, actually showed, and it was really effective. You can actually multiply up and down by the same thing here. Multiply by the reciprocal, 3x plus 5 over x minus 1, and 3x minus plus 5 over x minus 1. Notice that that will divide away these guys. And instead we'll be left with the limit as x goes to 1 of this square root thing, which we're going to still have to deal with at some point here, times 3x plus 5, all divided by x minus 1. So there's our stuff. Notice still, if we were to plug in 1, we'd still get 0 over 0. So we're not done. And of course, the reason for that is we're not done because of that square root up there. We need to deal with the conjugate. So now I'm finally going to do my attack. In fact, I don't even need another equal sign yet. I'm going to multiply up and down by the conjugate, which will be the square root of x plus 3 plus 2. I'm going to do it in the denominator as well. We talked about how that's how we have to do this to maintain balance. So that way we haven't actually changed the limit. We're just changing the way it looks. So looking here, if we go to evaluate our limit as x goes to 1, in our numerator, we've got again that difference of squares that comes from this piece. Of course, the pieces that aren't changing, we have the 3 quantity x plus 5. Now as I look at this numerator, x plus 3's square root squared is going to be x plus 3, and minus 2 times positive 2 is going to be minus 4. So in looking here, of course, our goal through this whole thing was to eventually get rid of whatever factor it was that was causing the 0 over 0, that indeterminate form that we didn't want, and I can finally see it. X plus 3 minus 4 is the same thing as x minus 1, and that means that these two guys are going to divide away. So given all of that mess, and again, as I'm writing this whole thing out for the 15 billionth time, let me remind you that, again, I'm showing every single step here, trying to be as careful and as slow and methodical as possible. When you do it, or when I'm doing it on an actual standard quiz or practice thing, I'm going to go much faster. Just keep that in mind. So on here, we're going to be left with 3 times x plus 5 over the square root of x plus 3 plus 2. When we look at this, we no longer have any zeros that can be created by evaluating it at 1. So I'm going to just go ahead and direct substitute. We'll have 3 times 1 plus 5 over the square root of 1 plus 3 plus 2. Looking at our ingredients, we'll have 3 times 6 over 2 plus 2, which is 4. 18 over 4 is our value. That could be our final answer, but of course we can simplify that just a little bit further down. So we will. We get 4.5, also known as 9 over 2, as our final limit value. And so there it is. You've seen a couple good examples. You've seen one of each of the algebraic techniques to quote-unquote trim the quills and evaluate one of those limits. You've also seen a piecewise function having a one-sided limit evaluated, and now you've seen kind of a tough algebraic combination of everything.